Hello students, in this video I will be showing you how to calculate binomial probabilities using Excel. This is the section, the binomial distribution, from the chapter Discrete Probability Distributions. If you need help understanding the difference between PDF and CDF or the different scenarios that you can have for calculating probabilities, please refer to the previous videos where I go in detail on the difference between exclusive and inclusive intervals, the different scenarios that you might have. And I already showed you how to calculate this PDF probability or PDF function. Use the PDF function for calculating the probability of exactly a value in the first video, the one where I introduced the binomial distribution. Let's go back. Using the exact same example from the first video, the Pew Research recently reported that approximately 30% of the internet users in the United States use the website Pinterest. Suppose that a simple random sample of 15 internet users is taken. Let's take a look at the information provided. We know that approximately 30% of the internet users use Pinterest, and we're taking a simple random sample of 15 users. Our number of trials in this case is 15. We are going to have as a success whether we get a Pinterest user, as a failure if we get a not Pinterest user. Our probability of success is 0.30, which we took from the 30% of users in the United States. Our probability of failure will be 1 minus that 30, which is 0.70. And yes, we consider this a probability independent event. And we're going to be computing probability for this independent event. Our first sub-question was find the probability that exactly 4 of the sample people used Pinterest. We had already learned how to use the formula to compute this. Using Excel, you're going to need the command binomial distribution equals binom.dist, and then you're going to input these different values. The first value will be the X outcome that you have, whether it's CDF, or it's PDF. The X value that you're using as a reference point is going to be the same. Then your second value will be the number of trials that you have. In this case, for this question, we had 15 sampled users. And then you're going to put your probability of success, which for us was 0.30. And then the last question, or the last portion, you're going to answer the question whether it's true or false, that you're looking for a cumulative probability, or just in this example, think of it as PDF or CDF, but you're only being asked CDF, yes or no. You're going to put true if you're looking for the probability up to that point, and you're going to put false if you're looking for the probability of exactly that X outcome you're looking for. In our scenario here, we are looking for the probability of exactly 4, which means we're going to put false, like the picture denotes here. So let me go to Excel. I'm going to be labeling them over here. The probability of exactly 4. As per our formula or our command, it will be equals binom distribution. Right here is this option. The first value, what's our X value that we're looking for? I want exactly 4, just 4. Number of trials, 15. Probability of success, 0.30. And then true or false. Do I want cumulative distribution function or probability PDF? I want PDF. I put false and then hit enter. That's my probability of getting exactly 4 users of Pinterest, 21.86%. Let me draw it. Let's look at our second scenario. We want to find the probability that fewer than 3 of the people use Pinterest. Fewer than 3. Notation or wording in this case is very important. Fewer than 3 does not include 3. We want the probability of X is less than 3. If we have our distribution, it doesn't matter what type of distribution you have. Let's suppose we have here the probability of 0, the probability of 1, the probability of 2, the probability of 3, the probability of 4, and then it keeps on going all the way to 15 because we could have up to 15 all of the people using Pinterest. I want the probability of fewer than 3. This is my X value, but fewer than 3 does not include 3. So I want the probability of at most 2 or up to 2. This is my X value. This is my X. This 2 is my X because I want it up to that value. It's important that you understand the difference between fewer than or at most 3 because one includes and the other one does not include the number 3. Because we're looking at discrete probability distributions, that's the reason why we do not include the 3. If it was a different, we're going to be learning different scenarios, and on the following sections, there's no difference whether you include or not the 3. For this binomial distribution, it's very important because you have to go back one value. Your CDF formula, the command in Excel, gives you up to whatever X value you give them. We don't want up to 3, we want fewer than 3. I will have to choose the 2. So in other words, you're looking for the probability of X is less than or equal to 2 because this is the one that I can compute. I can only use this command in Excel. I go to Excel. Now I want the probability of fewer than 3. Oh, sorry. Fewer than 3. I didn't write the notation in the form of X. The probability of X is equal to 4 was the previous one. This is the probability of X is fewer than 3, which we changed to the probability of X is less than or equal to 2 because our command only gives us up to that value, including the value. I'm going to put binomial distribution. My number of values that I now want for, it's 2. So I'm going to put here first 2. Number of trials, it's still 15. I still have 15 sampled people. The probability of success didn't change, it's 0.30. And now, do I want cumulative? Yes. Now I'm going to put true because I want 0, 1, or 2 people. But I don't want 3. Fewer than 3 does not include 3. My probability is 12.68%. Next scenario. We want to use the binomial probability distribution to find the probability that more than one person uses Pinterest. More than one person. More than one, does that include the 1? No. I want the probability that X is greater than 1. More than 1. You can find the probability to the right of a value, of getting a value greater than value, but it's faster to use the complement rule we learned a few classes ago. Remember that the probability of at least one could be found by using the formula 1 minus the probability of none or the probability of 0. Why? Because if we have, let me show you the example. We have 0 users, 1 user, 2 users, 3 users. We have all of these probabilities. I could find in my, when I pick out 15 people at random from the population or from this, for this survey, I could get 0 users, 1 users, 2 users, 3 users, 4 users, 5 users, all the way to 13 users, 14 users, 15 users, right? And I'm looking for the probability that more than 1, which means I have more than 1 is 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, all the way to 15. Just like we did with the probability of at least 1, it's faster to compute just the probability of at most 1 and then subtract the rest. So I'm going to compute the probability of this portion, and then I'm going to subtract it from 1 because the total sum of my probabilities is 1. I'm going to find, instead of finding the probability of more than 1, I'm still going to find the same probability, but I'm going to first find the probability of at most 1, including the 1. X is less than or equal to 1, and I'm going to subtract it from 1 in order to find the probability of 2 or 3 or 4 or 5 or 6 all the way through the probability of 15. Let's compute the probability of X is at most 1 in Excel. Oh, sorry. P at 1, or the probability of X is equal to, like X is less than or equal to 1. My command is binomial distribution. The number of my key number in this case is 1. I'm looking for X is less than or equal to 1. My number of trials is still 15. My probability of success is still 0.30. And do I want cumulative? Yes. This is the probability of at most 1. Remember, I have to subtract it. I have to subtract it from 1. 1 minus, equals 1 minus this, 96%. So this is the probability of more than 1, or the probability of X is greater than 1, 96.47%. Remember, to find this, I subtracted the probability of at most 1 from 1. I put the equals just to take calculation, 1 minus, and I put this probability, 0.0352 or 53, 0.0353, 0.9647, or 96.47%. So the probability of more than 1 is 96.47%. Now, our next scenario. Find the probability that the number of people who use Pinterest is between 1 and 4 inclusive. 1 and 4. 0, 1, 2, 3, 4, 5, 5, 6, 7, 8, all the way to 15, right? Between 1 and 4. This inclusive means that I include the 1 and the 4. I want from 1 to 4. Remember, my function, my command in Excel gives me up to a number. What you can do is compute the probability up to 4 and then subtract the probability of 0, or you can compute this probability, the probability of more than 4, add the probability of 0 and subtract from 1. There's multiple ways of answering this question. I'm going to find the probability up to 4, up to here, which is the probability of X is less than or equal to 4, and I can find this in using the Excel command. And then I'm going to subtract the probability of exactly 0 to take away this portion right here. Let's do it. The probability of at most 4, which is going to be the probability of x is, x is less than or equal to 4. I use the command equals binomial distribution, The number of values that I'm looking for is 4, at most 4. The number of trials I had was 15. The probability of success was 0.30. And yes, I'm looking for cumulative. That's the probability of at most 4, or x is less than or equal to 4. Then I'm going to find the probability of 0, of exactly 0. The probability of x is equal to 0. Binomial distribution command. The value that I'm looking for now is 0. Number of trials 15. Probability of success 0.30. Do I want cumulative? No, I just want the probability of x is equal to 0. That's the probability of x is equal to 0. And remember, I'm going to subtract this one from this one to find the probability between 1 and 4 inclusive. So the probability of 1 is less than or equal to x, which is less than or equal to 4. This is the notation we're going to be using for the probability between 1 and 4, including 1 and 4. It's this one, and I'm going to subtract, I forgot the equal to the node calculation. This one minus this one. That's the probability, 51.07%. I forgot 0.7. And the notation for this one was the probability of x is in between 1 and 4, including 1 and 4. All right, what's the probability that exactly 5 of the sample people use Pinterest? The probability of exactly 5, we go to Excel. We go to Excel. The probability of exactly 5, that's the probability of x is equal to 5. Using the same command, binomial distribution, 5. Number of trials 15. Probability of success 0.30. Do I want cumulative? No, I just want exactly 5. 20.61%. And this is how we keep on using that exact same command to compute the different probabilities we have. Feel free to keep on practicing. We had 2 more. Let me keep on doing them. The probability that fewer than 4 of the people use Pinterest. Fewer than 4 does not include 4. I go 1 before 4, which is 3. So the probability that x is less than or equal to 3. Because the probability of x is less than 4 does not include 4, and our command in Excel only allows me to find up to the point. I have to go 1 before that. For the probability of x is less than is it fewer than 4? Oh, sorry, no, it was 3. Less than or equal to 3. The command binomial distribution. 3 is my x value in this case. Number of trials 15. Probability of success 30. Do I want cumulative or PDF? I want CDF. 29.69 is my probability. With practice, you're going to be able to do it a little bit faster. What's the probability that the number of sampled people who use Pinterest is between 6 and 8 inclusive? So we want the probability of X is in between 6 and 8, including the 6 and the 8. Remember how we did it last time? I found the probability of at most 8, and then subtracted the probability of at most 5. Because I do want to include the 6, so I have to go one before. This is because, let me highlight them. 5, 6, 7, 8, 9, all the way to 15 sample people. I want the probability between 6 and 8, including the 6 and the 8. I'm going to find the probability up to this point, and then I'm going to subtract, which is this one right here. And then I'm going to subtract what I don't need. I don't need the probability up to 5, which is this one right here. Let's compute it using Excel. Let me move this. I need a little bit more space. I need to use the command twice. I first need to find the probability of X is at most 8, or X is less than or equal to 8. And also the probability of X is at most, of X is at most 6. Oh, wait, at most 5. I have to go one before, don't forget that. Binomial, distribution, the number that I'm looking for, 8. Number of trials, 15. Probability of success, 30. Cumulative, yes. And then for the one that I'm subtracting, again, binomial, distribution. This time my key number is 5. Number of trials, 15. Probability of success, 30. Cumulative, yes. I want up to 5. So to find the probability of X is in between 6 and 8, or X is in between 6 and 8, including 6, including 8, I have to subtract these two. I'm going to subtract 0.7216 from 9847 equals to the node calculation. This one minus this one. 0.2631 is my probability, or 26.31. 26.31%. These are the steps you have to follow if you're looking for your probability using Excel. Thank you.